Hi class, and welcome to our notes on 5-6. What we're doing in this lesson is we're rationalizing the denominator. There's two big words that I want you to see here. Those words are rationalizing and denominator. Let's break down these two words so we can see what it's saying to us. With every fraction, there is a numerator and there is a denominator. So what we're going to do is we're going to rationalize the bottom part of our fraction or our denominator. So now let's talk about the word rational. Rational numbers are numbers that can be written as a fraction. Irrational numbers are decimal answers that go on forever and ever and ever. Most oftentimes they're square roots, such as maybe the square root of 17. If you take the square root of 17 in your calculator, you don't get a nice clean number, you get a decimal, 4.123105626, and this number actually continues to go on forever and ever and ever in a random order. There's no repeated pattern with these irrational numbers. So what we're trying to do with this lesson is we're trying to rationalize the denominator, or get it to be a number that can be written as a fraction. And most oftentimes in this lesson, it's an integer. So 1, 2, 3, 4, so on and so forth. That's what we want to get in the denominator. Mathematicians do not like to see irrational numbers in the denominator, so this lesson is rationalizing it. So making the denominator have no radicals in it. So we look at problem number 1, and you should have a red flare that goes on in your brain right now saying, we see a radical in the denominator. This can never, ever, ever happen. So we need to rationalize the denominator. The way I get the denominator to be rational is I multiply it by itself, or I square the denominator. Because if you take square root 14 times square root 14, you get the square root of 196. And what's the square root of 196? The square root of 196 is 14. So the way you rationalize the denominator is you multiply it by itself. Square root 14 times square root 14 is 14. So that's my goal in this lesson. Now, what I do to the bottom, I must do to the top. It's a fraction. So if I want to make 2/3 an equivalent fraction, maybe I want to make it as a denominator of 6. Well, if I want to get it to be a denominator of 6, I have to multiply the bottom by 2. But if I'm going to make an equivalent fraction, if I multiply the bottom by 2, I have to multiply the top by 2 as well, so I end up getting 4/6. Because 4/6 is an equivalent fraction to 2/3. So bottom line, whatever I do to the bottom, I got to do the same thing to the top to make it an equivalent fraction. What I do to the denominator, I must also do to the numerator to make it an equivalent fraction. So, here in my numerator, I now have a negative 4 times the square root of 14, which is just a negative 4 square root 14. So, there I have it. I've successfully rationalized my denominator because I see a positive 14 down there now. So, my answer is a negative 4 square root 14 over 14. Now, this would be our answer unless we could simplify anything. We can't simplify our radical any further. The square root of 14 is as simplified as it gets. However, my coefficients can be simplified. 4/14 reduces to 2 over 7. So whenever you can reduce top to bottom, make sure you do that. So my answer is a negative 2 square root 14 divided by 7. Now that is as simplified as I can make it, so there's my answer. I circle it and move on to the next one. You cannot reduce 14 divided by 7. You can't do that because the 14 is underneath the radical, whereas the 7 is not. So you can't cross over between those two. So make sure you understand that. Negative 2 square root 14 divided by 7 is our answer for problem number 1. You guys pause the video and try number 2 on your own. After trying number 2, you should have multiplied both top and bottom by square root 17. So when you do that, you get 17 in the bottom, because square root 17 times square root 17 is 17. And then in the numerator, you get a negative 17 times the square root of 17. So now we reduce. 17 divided by 17 is 1, so we have this negative 1 times the square root of 17, or just a negative square root 17. There's our answer for problem number 2. Problem number 3, we jump a level of difficulty slightly, but the same concept exists. We're going to multiply both top and bottom by whatever the radical is. So if the radical is 5q, multiply the bottom and the top by the square root of 5q. So in the bottom, the square root of 5q times the square root of 5q is 5q. And in the numerator, square root of 15 times square root of 5q, you multiply the numbers underneath the radical, and you get the square root of 75 times q. So you've successfully rationalized the denominator. That's great. Now we need to simplify if possible. And 75 breaks up into 25 times 3. So now you have 25 times 3q divided by 5q. Let's keep breaking this down further. We know what the square root of 25 is. The square root of 25 is 5. So this can come outside the radical as a 5. And underneath the radical, we're left with 3q. And in the denominator, we have 5q. So I'm going to reduce top to bottom again. 5 divided by 5 is 1. So I am left with the square root of 3q in the numerator and q all by itself in the denominator. Once again, you can't divide q by q in this case because in the numerator it's underneath the radical, whereas in the denominator it's not underneath the radical. So make sure you don't reduce those. Square root 3q divided by q is our answer. Number 4 is a slightly different animal. We can reduce this first before we rationalize the denominator. Here's what I mean by reducing this. In a previous lesson, we found out that as long as both of these are underneath the radical, we can simplify it first. So I'm going to put everything all underneath one radical and say it's 108 x to the 7th y divided by 3x to the 5th y squared. Please write that underneath the same radical just as I have it on my smartboard here. And now what I want you to do is I just want you to reduce top to bottom. 108 divided by 3 is 36. X to the 7th divided by x to the 5th is x squared. Y divided by y squared is y in the denominator. So now you see this, but it's all underneath the radical. So now that we see this, we can now split it up into two different radicals again. In the numerator, we have the square root of 36x squared, and in the denominator, we have the square root of y. So we still haven't rationalized our denominator yet. You still see an irrational number and a square root of y in the denominator. We can simplify this. The square root of 36 is 6. And then the square root of x squared. Remember how whenever you have an index of 2, you take your exponent on a variable and you divide it by your index? So you take 2 and divide it by 2 and you get 1. So you could bring out an x to the first power. So the square root of 36x squared is 6x. That is divided by the square root of y. Now this looks very similar to problems number 1 and 2, where all you need to do here is multiply both top and bottom by square root y. And then we got it made. 6x square root y is in our numerator. Square root y times square root y is y. That is in our denominator. And there's our answer. We are done after this. Okay, problem number 5 now. If we look at a negative square root 3 divided by the square root of x, this is one that similar to ones that we've done in the previous slides. I want you guys to pause the video now and try this one on your own. You should have multiplied both top and bottom by square root x. So once you do that, a negative square root 3 times the square root of x is a negative square root 3x. And in the denominator, square root x times square root x is x. In class, you could try to simplify this further, but that's as simplified as you can make it. You can't simplify the radical in the numerator because the square root of 3 doesn't reduce, the square root of x doesn't reduce. You can't reduce anything top to bottom in any way, shape, or form. So our answer is left at that, a negative square root 3x divided by x. Number 6 is a little bit tricky. Don't write this down right away. I'm going to write some things and I don't want you to write it. What you could do, class, is you could follow our same rules that we've been talking about in multiplying both top and bottom by whatever the radical is. So you can multiply the bottom by square root x to the 5th and the top by square root x to the 5th, and you can go through all the right mathematical procedures and you're going to get the right answer. So if you want to do it this way, you certainly can. But you're going to go through a little bit more work than you would have to if you did something maybe slightly easier. So I'm going to erase this. Now whatever I write down on my smartboard, I want you to write it as well. When I look at the square root of x to the fifth, that's an irrational number because I see a radical. So if I want to rationalize the denominator, if my index is 2, which it is, as long as my exponent is even, I can bring out an exponent whenever I have an even index. Here's what I mean by that. Don't write this down. If I have x to the fourth, what's the square root of x to the fourth? It's x squared. And now I have a rational answer in x squared. If I had x to the 22nd, the square root of that, I divide it by 2 and I get x to the 11th. If I have x to the 30th power, the square root of that, well, I simply divide by my exponent by my index, and I get x to the 15th. So as long as my exponent is even, I can always divide it by 2 and get a rational number. So what is the easiest way to get the square root of x to the fifth an even number? The easiest way of doing that is to multiply both top and bottom by just the square root of x. Here's why, class. If you look at your denominator now, you multiply your numerators by each other. 7 times 1 is still just 7. And square root x to the fifth times square root x to the first, with common bases, you add their exponents, and you get the square root of x to the sixth. Bam! Now this is positive. So once that's positive, I can now take the square root. I shouldn't say positive. Now that's even. 6 is even. So once I get my exponent to be even, I could easily take the square root of it by dividing by 2. What I do to the bottom, I must do to the top. So we're going to multiply the top, and I get a negative 10 square root 10x. All right, let's finish this one through. In the numerator, I can't simplify anything further. I can't reduce the square root of 10 in any way, shape, or form. So in the numerator, I'm just left with a negative 10 square root 10x. In the denominator, I can take the square root of x to the sixth. I simply divide by 2, and I get x to the third, because 6 divided by 2 is 3. So I still have a 7 outside the radical, and now I have an x cubed, and there's no more radical in the bottom. I have successfully rationalized my denominator. And there's my answer for problem number 6. Definitely a difficult one. Make sure you let me know if you have questions on that one when you get to class tomorrow.